This was the Newton's first law. So we said that the acceleration here is caused by some external force. So we can say that, but there is a problem. Suppose a body here, if a force is acted onto it like this, it will come, for example, it's at rest, it will come in motion. But if another same force is acted in the opposite direction, one force is acting, F1 is like this, F2 is like this, and both cancel out each other, what will be the end result? This body will stay in the state of rest, because both of these forces are cancelling out each other. Fine. So that means if the total sum of the external forces, say for example here another force is acted onto it, here another, this cancels out this cancels out this, another force like this, another force like this, these two cancel, another force like this, but here another force is like this cancels this very thing. So that means the sum of the total external forces, that is the resultant net external forces. Resultant are the net external forces. If net external forces onto a body is 0, they are cancelling out each other. Similarly, in case of the moving bodies, if the total forces acting onto the bodies are cancelling out each other, that is the net resultant force is external force, I am saying, is 0. That means there will be no change in its original state. That means no acceleration will be brought in. Okay, you saw here that acceleration is brought in by what? By some external force. But here force is applied, but forces are cancelling out each other. That is the net acceleration, net external force is 0. That means if a body is observing a net force of 0, external force 0, that means there will be no acceleration. Or in other words, if a body is not accelerated, at all, if it is moving in a uniform motion with a uniform velocity, that means there will be no acceleration, and that in turn means that no external force is acting onto it. Or this is equivalent to saying that the total forces, if there are more than one force, two forces, more than two forces, then the resultant of those very forces is actually 0. Because it is as if the total forces are acting onto it. It is as if that no force is acting onto this body. So that's because no acceleration is observed onto this. Like I can elaborate this very concept in another example. I will give another example to you. For example, say here is a table. Okay, and we are keeping a book onto it. This is a book onto this. Okay, now I'm saying to you, is this book at rest or moving? Clearly it's at rest. It is at rest. That is, we know from the first law of motion, there must be the acceleration is what? Acceleration is 0. That means the external force must be 0. For here, we know what kind of forces are acting onto it. Like we see here, no force is acting. But in reality, this body has got mass m. Okay, so downward, always there is a gravity downwards. So the weight of the body is downwards. Weight of the body is, for example, this pen. If it is possessing a mass m, there is always a gravitational force downwards exerted by, I discussed it earlier also in the fundamental forces, the gravitation. So gravitational force will be acting downwards. Okay, here will be the gravitational force like mg. So there is an external force, but since we are observing 0 acceleration, that means this force is counterparted by some another force, and in this case it is upwards force. So this book, which is here, it is acted upon by two forces, mg, that is the weight of the body, which is the downward force, the force of acceleration, and it is counterparted by some by another force, which is called as a normal force. And the normal force is caused due to the contact between two bodies. Here that means the table and the book itself. So there comes another force, that is the normal force, which cancels out the downward gravitational force. So the net result is n plus mg is 0. That means n must be the opposite to mg. So acceleration due to gravity, which is causing the gravitational force, is opposite that of the normal force. So in this case, we saw that the body will remain at rest because the net force is 0. So there will be no acceleration in the body. This is given by the first law. Similarly, you might have heard about if we are in a bus, for example, this is a bus, and it's moving with the velocity, something velocity, and we are standing in this bus. If the driver here applies brakes suddenly, so this comes at halt, this comes stop, the bus is stopped suddenly, we feel what? Forward jerk. Why? It is because the property of inertia inside our body was first moving with the velocity, with the same velocity with the bus was moving. So our body tries to remain in what? Uniform velocity. But now our feet are in contact with the bus, exerting some force, and the frictional force is exerted onto our feet. So our feet are at the instant time when the brakes are applied, our feet come to rest with the bus, but the upper part is not. It is still in moving with velocity. So that means our upper body will feel a forward jerk. Similarly, when the bus is at first, if it is set in motion, we will feel a backward jerk. That is because of the property of the law of inertia, okay? Because our body possesses inertia and our body tries to remain in its original position. So that's all for today. I hope you got this idea. These are the basic concepts in the physics. So in the next time, I will deal with the momentum and other kind of stuff. So this was all about the first law of motion. I hope you got it. Kindly support and cooperate. I will see you in the next.